Hello, mathletes. 12.7 Graphing Trigonometric Functions. So, a trigonometric function is a periodic function, which means that it has a pattern that repeats over and over again. In other words, a cycle, right? So, a cycle is one complete pattern of a periodic function, and a period is the length of that cycle. Okay, so it's the length of one cycle. Amplitude is the height or the vertical distance of the graph from the baseline to the top. And by the way, sine functions and cosine functions are wave functions. So when you talk about amplitude, you're talking about the height of the wave, basically. All right, and then frequency is the number of cycles of a periodic function over a certain period. So we'll see these vocabulary words in action here in a little bit, and hopefully they'll make a little more sense too. All right, so let's talk about why we have, or what a trigonometric function looks like and why it's periodic. So remember that functions have an input-output relationship, right? So if I have f of x equals sine of x, then my input is whatever that angle is, and my output is the ratio, right? And so, for example, if I input 0 degrees, sine of 0, remember sine is equal to y, so sine of 0 is 0. Sine of 30 is 1/2, right? Sine of 45 is root 2 over 2. So what's happening here is our values are increasing, right? So we're going from 0 to 1/2 to root 2 over 2, which is bigger than 1/2. Sine of 60 is root 3 over 2, which is larger. And then sine of 90 is 1, which is larger than root 3 over 2. Okay? And so we went from 0 to 1. And remember, that's the highest that sine can be. So now it's going to start going down. Now it's going to go back to root 3 over 2. Sine of 120 is root 3 over 2. Sine of 135 is back to root 2 over 2. Sine of 150 is back to 1/2. So it's repeating what we saw over here, right? So it's going up, and then it's coming back down as our angles increase, right? As we get to 180, we're down to 0. So what happened was we went up to 1 and came back down to 0, right? And now what's going to happen is as we get to 210 and so forth, now we start getting those negative values, negative 1/2, negative root 2 over 2, negative root 3 over 2, negative 1, right? So now it's going, if this is the x-axis, now it's going below the x-axis, right? Down to negative 1, okay? So it went as high as positive 1, now it's going as low as negative 1, and that's the lowest it's going to go, and then it's going to start going back up again, negative root 3 over 2 at 300. At 315, negative root 2 over 2. At 330, negative 1/2. And then at 360, back to 0. Okay? So what happens is it comes back up to 0. Okay? And then it's going to go through the same pattern again. If I go past 360, say I go to 390, that's coterminal with 330, right? Or 405 is coterminal with 45 and so forth, right? 420 here, 450 here. And so what's going to happen is if I keep going up there, I'm going to go through the same pattern again. It's going to go back up 0 here, 1/2, root 2 over 2, root 3 over 2, 1. And then it's going to come back into the second quadrant, right? And it's going to go back down towards 0. And then it's going to go negative, and then it's going to come back up, right? And so this pattern is going to continue over and over again, okay? And so let me put in the y-axis here. So this is at 0, right? At x equals 0, where the angle equals 0. And so what we have here is we have the period, which is from start to finish of one cycle, okay? So we started at 0. We came back to 0 here, but that's not the finish of the cycle, right? The cycle is the whole pattern, okay? So the pattern is like that, right? It goes up to 1, down to 0, back down to negative 1, and then back up to 0. Then it starts the pattern all over again, right? If I took this pink trace here and I I mirrored it starting here, it would be the same thing from here to here, right? Like I could just take that pink trace and put it on this point, on this part of the graph, and it would be the exact same. Okay, so that's the period is that pattern, that cycle. Okay, all right, and what we notice is the period is from 0 to 360, right? That's what it takes to make a full rotation around the unit circle, or around any circle really for that matter, right? And so period of a sine graph is 360. Okay, so then one more thing about the graph is we have amplitude. So amplitude is the height of the graph. It's the height from the x-axis, or from the baseline. The baseline is kind of this middle line here to the top of the graph. And so the default baseline is 1, or the default amplitude is 1. Okay, and if you go down here, it's -1, right? But the distance from the baseline to the top of the graph is 1. The distance from the baseline to the bottom of the graph is also 1, right? So that distance is 1 either way. So that's the amplitude, is the height basically of the curve from the baseline to the top of the curve, or the baseline to the bottom of the curve. All right. So let's we'll take a look at the trig functions here. So these are the graphs of the trig functions, right? And you can see here that we have our amplitude of 1. Okay, and basically the outline of a trig graph is like this: y, or let's just say sine function. So it's y equals a sine x, and a is the amplitude. Okay, so whatever a is the amplitude, or at least the absolute value of a is the amplitude. Okay, so if a is negative, that flips it upside down, like we know about reflections across the x-axis. But the amplitude is always a positive value. It's always the height of the graph. Okay, so even if it's negative, the amplitude will be positive. So if I put a 2 in front here for a, that's going to stretch it out to where the graph's going to go up here to 2, right? And then it'll go down to -2. Okay, all right. Now you see these graphs here in radians, but just remember this is we can convert this to degrees as well, right? All right. Okay, so so that's the amplitude, the period, and let me just put a value here in front of x here. So remember that whatever we put in here, oops, right and drawn to. Okay, so this is a vertical stretch or compression, right? So that stretches the amplitude, whereas this is a horizontal stretch or compression. So that stretches stretches or compresses the period, right? So the period of sine and cosine, and secant and cosecant. So sine, cosine, secant, cosecant. And it's a little different for tangent, but the period for these ones is 360 over b, because remember that everything that happens inside there is backwards. So you'd think if b was bigger than 1, it would stretch horizontally, but it's actually going to compress. So we always divide by whatever b is. Okay, and that's going to be the period. All right. Now for tangent and cotangent, the period is actually just 180. And so it's 180 over b. So if you don't see a b there, then it's just 360 for these 4 functions and 180 for tangent and cotangent. Okay, so tangent and cotangent, going back to the unit circle, they actually, because they alternate from positive to negative to positive to negative, their period is actually just 180, because they alternate every 180 degrees. Okay, so their cycle repeats every 180, not every 360, like sine and cosine and secant and cosecant do. All right. So let's graph. We'll graph cosine and sine, and then we'll talk about how to graph secant and cosecant, and then we'll talk about tangent and cotangent. Okay.